So those of you that are in tune and with it have identified, wait a minute, 923, we were just in 914. We're skipping, right? So to make you aware of what we're skipping, because you're going to fill in these gaps next year, but I just wanted you to know what was up. The beginning sections, I did not mean new window. Yes, when you work ahead, as I've said, you might not understand what's going on.
No, I understand.
So in 921, we talked about side lengths of triangles and right triangles versus not right triangles. And you'll do more with this next year. Like, you'll continue doing a lot more. And in 922, we talk about the Pythagorean Theorem. I don't like to just breeze over this because kids like to know the Pythagorean Theorem because it's like a popular thing that in mathematics we use a lot. So real quick on your notes, we're going to hit this before we dive into 923. The Pythagorean Theorem is used on right triangles. My smartboard's really mad at me today. I don't know what I did to it, but it won't let me write on it unless I'm using smart software.
I think it's because you used the other smartboard and it's stored.
The other pens? Yeah, I realized what I did.
Yeah.
Curse your son, but inevitable betrayal.
Yeah.
On your graph paper, please make a triangle that is 3 by 4 and then connect the line. So here, hold up. 3 tall, 4 what? That triangle is not the right triangle tool. Three tall, 4 wide. And the Pythagorean Theorem says that if we call the legs of our triangle A and B, and by legs, we mean the legs are the base and height which have to be perpendicular. So in a triangle, the base is perpendicular to the height. Guys, this is very much a math sentence. This would read in a triangle, well actually this should really be in a right triangle, but in any triangle, the base is perpendicular to the height. In any triangle, the height compared to base, even if this isn't a side, it's perpendicular. Then, in a right triangle, the height has to be one of the sides. So where in a regular triangle it might be like the height would come up in the middle, the height has to be the side, and it has to be perpendicular. So then we call the base and the height A and B. And really all we care about then is that the hypotenuse, what does hypo mean?
No.
Under.
Under.
If I rotate this triangle, the hypotenuse is under the right angle. The hypotenuse is under the right angle. We call that C. That's all you really need to know. And the equation is A squared plus B squared equals C squared. Now we're going to talk today about what square ring is. And we talked a little bit about it already. Who can remember, or who might know more than what we've already taught you? What is square ring?
Squaring is timesing a number by itself.
Timesing a number by itself. So the Pythagorean Theorem says 3 squared will be 3 times itself. 4 squared will be 4 times itself. Well, so that's 9 16. So this equals 25. We're trying to look for some number when times itself equals 25.
So we're doing square root.
So then you square root it.
And then you square root it.
This is the most famous right triangle. The 3, 4, 5 right triangle, seriously, is used by many people every single day in the quote-unquote real world. If I'm building a patio, which I used to do for 3 summers, I was a landscaper, and we lay out the frame of the patio, it's hard to know if I have a perfect right angle. Like, our eyes looks like a right angle, but I'm off by 3 degrees. 10 feet later, that 3 degrees is a big gap because it gets bigger and bigger and bigger. To check a 90-degree angle, you measure 3 feet, 4 feet, and the distance between those points should be 5. If not, you fix it like somebody's backyard measuring with stakes and permanent markers, that's exactly how we would do it. Seriously, 3 feet, 4 feet, 5 feet, gotta be. Perfect. You check all your corners, good to go. This is not everything you need to know, but this is the basics of the Pythagorean theorem, and this 3, 4, 5 is actually called the Pythagorean triple. So there's a few more Pythagorean triples, but a Pythagorean triple is any right triangle that has perfect whole number measurements. So if I go 3, 5, this will not be a perfect whole number. I can make a right triangle that's 3 by 5, but this will be some ugly number that's probably going to be like 6 point something, maybe 7 point something. So that's the Pythagorean theorem. Real quick explanation. I hope you plan on cleaning all that up. Otherwise, Mr. Shoup is going to come hunting you down.
Yes, I do. I plan on sweeping it all up and throwing it in the trash.
Square roots. So squiggly line if you want. Now this was the other reason that I felt like I just couldn't skip 922 completely. So imagine you're back in Pythagoras. When did you live? 1600s? I forget when Pythagoras lived. Long time ago. Now, a little bit of today is going to be a bit of math history. Yeah. Pythagoras, if I didn't show you guys the little Math-O-Magic video that I sometimes do, Pythagoras had a group of people that followed him, known as the Pythagoreans. No joke, this is all true. And it was like a secret society, kind of secret, like some people knew about it and they knew to keep it a secret, that they were all about like solving math problems and like investigating things and trying things out, and they were like really trying to become smarter. And actually they had a secret symbol that was the pentagram, which now an upside down pentagram is normally associated with like demonic type worship or whatever, but a regular pentagram is just a star. It's a 5-sided star, but specifically a pentagram perfectly has a pentagon inside of it, and then has all congruent triangles around the outside of it. So there's a lot of mathematical properties inside this pentagram that they were very, very interested in. As they were studying their mathematics, they stumbled across what they thought was a mathematical truth. Ugh. A squared plus b squared equals c squared. Right? So that Pythagorean theorem, what's a theorem, by the way? What's the difference between like a theorem and something else, a conjecture, a fact, or like, yeah.
I don't know with that, but earlier when I think you were, when most of the teacher brought it up, that little plug thing under the starboard fell.
Okay, that's totally fine. That is not why that's happening right now. Thank you, though. But this is my computer needs restarted, essentially. Because I can write on my other screen. It just won't let me write on here. So, Pythagoras said, a squared plus b squared is c squared. And people are like, you sure? And he's like, yeah, no, like, trust me, it works. And they're like, you're smarter than us, so we don't really believe you. He's like, guys, try out any triangle, it works. And they were still like, So finally Pythagoras gets mad, right? He's like, fine, I'll go beyond triangles and prove this to you. They're like, okay, what do you mean? Redraw your 3, 4, 5 triangle. We're going to go rogue from CPM, but give yourself space around it too. Redraw your 3, 4, 5 triangle.
How so?
Like, just leave yourself enough space that you can essentially make that image.
Oh, yeah.
But we're using different dimensions.
I never marked it.
So Pythagoras is trying to prove to them that the leg of 3 when squared plus the leg of 4 when squared will equal the remaining side of the triangle. Does it take 2 people to draw a triangle? Like, what's going on, Braylon? Shall I come back there? Am I going to be happy about what's on your papers or not? Will equal the other remaining side, the hypotenuse. They didn't have a name for it back then, though, of 5 squared. So, squaring is a mathematical word, but it's also, it's an algebraic word, but it's also a geometric word, right? What's a square? It's not a trick question. What's a square?
A quadrilateral.
Yes. Give me more.
With all the sides are equal.
Give me more.
All the sides have right angles.
I don't know if there's more.
There's 4 sides, and it's in the second dimension.
Okay, second dimension. Yeah, you gave me more, but the quadrilateral gave me 4 sides.
It's a shape.
It's a shape. Now we're going backwards.
Yeah.
So Pythagoras knew that the people around him were not as intelligent as he was. So instead of trying to get them to understand the math, he just said, okay, let me draw you some shapes. If come on, draw a picture, right? If people don't like you and they don't understand what you're doing, draw a picture. So he drew a 3 square, right? A 3 square. 3 square. A 3 square.
Wait, that's why it's
Draw that. He then drew a 4 square. A 4 squared. And he asked the crowd around him, okay, let's see what we have now. So with the 3 square, how much do we actually have? 9 squares, right? 9 little squares. The big 3 square involves 9 little squares. The big 4 square involves 16 little squares. And if we make, now this is tough, I'm gonna cheat. Actually, I can cheat even more.
draw 5 and then push it up.
You bad. No. You cheated.
I knew you were gonna do that. Now just move it. Oh, you cheater.
Na boo boo. But guys, that was 5, right? On my graph paper, that was 5. This is 5. This edge, right? How many squares? 25. Now, here's where actually, in college then, Dr. Smith started to really make me scared.
How so?
So to do your best, and actually you could measure, and then
Well, that's a better idea. Yeah.
and it should be 5 squares. That diagonal line should be 5 squares of your paper, like length, 5 squares. Even though it's diagonal, so it's hard to count. So Dr. Smith comes into class one day. I need to find this mug. My room gets all moved around. And he says, would you believe me that you're better than Pythagoras? I was like, dude, I don't know if anyone's better than Pythagoras, because I mean, he's Pythagoras.
He's pathetic.
Now, I can't find that mug. It's somewhere in this room. But I have a mug that he then gave us. It's a plastic mug, in case you see it. That says better than Pythagoras. I think it says Mike Hudson is better than Pythagoras. What Pythagoras didn't realize back then, but now we've come to realize, this property actually holds true no matter what shape we put on the edges. So instead of just being able to operate as 3 square, we can actually expand this and say 3 pentagon, 4 pentagon, 5 pentagon, and it works. We can do it with octagons or decagons or any shape that we put on here. This property will hold true all the way to circles. And that's what's on that mug that I can't find right now. It's got to be somewhere around here. But this proof that Pythagoras made hundreds of years ago, like lots, I forget when he lived, but it was a long time ago, holds true way beyond he even ever imagined. This is where square roots come from, is having to do this process backwards.
I thought it was because it would resolve our problems.
Ha 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 ha. So, let's talk about 2 different words. Please on your paper write perfect squares. I can't write on, this is killing me because I can't write on that screen. Perfect squares, and if you want to write the definition, which would be of benefit to you, a perfect square is the result of squaring, that's red.
Oh, you fixed it.
No, it's just which software, like, in that screen, it won't let me write. This is Smart Ink, or this is Smart Notebook, right? It's better. The result of squaring an integer. Now be careful, we're not saying whole number. It's the result of squaring an integer. So 2 is an entire number, right? 2 squared is what?
4.
So 4 is a perfect square. -2 is an integer, right? Entire number. They can be negatives. Whole numbers can't, but integers can. What's -2 times -2?
No. 4.
+4. So 4 is a perfect square. Are there any conditions that we could put on perfect squares? Like numbers they can be or can't be? So what if we think about 3 squared to look for the next perfect square? What's 3 squared? 9. So 9's a perfect square. You might want to write that down. We can start listing these, and actually I had a student one year who wanted to see how many perfect squares he could fit on a piece of paper. So he took a piece of ruled paper and 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, all the way down, and drew a column, 25, 26, so he had a ridiculous amount of perfect squares. We can keep doing this all day long, right? But anytime we think about like negative, which actually technically, if you want your calculator to do it right, you would have to put your negative number in parentheses. Otherwise, your calculator is going to square it and then apply the negative, right? It can only do what it's been told to do, and that's order of operations. If we put it in parentheses, it's actually saying -5 times -5. Well, what is that? 25. So I'll ask my question in a different way. Can a perfect square be negative? No. Because anytime you take a number times itself, right, just 2 of them, a positive times a positive, always positive. A negative times a negative, always positive. Now, once we get into cubes, that rule doesn't work because it'll be a negative times a negative times a negative. These pair up for a positive, and we still have a negative left over, and this little piggy makes it negative. He didn't share his snacks or anything.
How rude.
All right, now the next vocab word. So do we get perfect squares? And if you want to write down always positive, you can. So the next vocab word is a square root. Now this is the part of this lesson that is harder to understand, so please stick with me. Square root is the value which, when squared, I don't want to use value twice. Our target number, or whatever you want to say, is going to be, we're going to define this.
Are you using Python now? Cool.
Value in the radical. Now wait, crap, radical, we're not a bunch of surfers because we live in Ohio. Radical is just a fancy way of saying the square root term, or the square root symbol. So actually, radical is the name of the symbol.
Oh, like
Square root is the result. So guys, hey, this is where like things you haven't thought about before. Addition is the symbol, right? What's the result? Sum. Multiplication is the symbol. What's the result? Product. See if you remember this. Division is the symbol. Result? Dividend or quotient. I love quotient actually because there's not very many keywords. So radical is the symbol. Square root is the result. Now that being said, I can ask you what's the product of 2 and 3. I can ask you what's the square root of 16. But I can also just say what is radical 16. Right? So the words are used like interchangeably. So here's where this gets kind of messy. Most square roots aren't perfect. So radical 16, if we square root a perfect square. I didn't write them up there. I can't use both screens today, but if we go back to our perfect squares, if we square root any of these, they will come out nicely because we're looking for what number when times itself equals 16. But
wait, there's more.
Didn't -4 also work to get 16?
Yeah.
Here's a new math symbol for you. The answer to radical 16 is actually positive or -4. That's what that symbol means. Because again, mathematicians are efficient. We don't want to do work we don't have to do. I'd rather just write one number with a special symbol. Now, all that, and I'm going fast. I'm kind of going through the lesson in whatever order I feel like because I want to go over your test today too. A few years ago, we had a student here named Rachel who came up with a method for dealing with some of these problems that aren't perfect. So we're going to look at a couple others that work nicely. Then we're going to look for the Rachel method. So take a moment and ask yourself, I think radical 9 is too easy. Is there a whole number that when multiplied by itself would result in those values under the square? Oh, by the way, the derivative of where this came from, give me your eyes again. Sorry, I don't want to skip over this because I'm going in my random order. What square root actually means, and we talked about this once at least because I remember this year, is how big is the edge of your square. So the square root, you can kind of think of like, what's the bottom of your square? The root, right? Well, the bottom will be the same as the side, but root, you can think about, so if my square has 81 units in it, that's square units, right? That's little squares, 81 little squares. The bottom edge length would be 9 because a 9 by 9 gets you 81. But what if it only had 80? This can't be 8 because 8 by 8 is 64. So this is where we get into like those non-perfects. So real quick, if we cover the 3 right here, what number times itself makes 49? Ooh, positive or -7. What number times itself makes 121? 11. And we put the positive or negative. And what number times itself makes 169?
I don't know.
13. That one's fun because 3, 6, 9. They kind of, you can remember the 6, 9 is multiples of 3. Now, I'm going to show you the approximation way. And then you can do it in a calculator too. Connor, what's up? Yeah, so that depends on which setting you have your calculator in. Again, you're asking a question that we're not there yet. Okay, you're just asking a question that's too deep. That's really Math 1 content. So, Google it. If you want to know about it, Google radical form. Actually, Google simplest radical form. So write this down right now if you want to know about it. Google simplest radical form is what you're asking about. Hey, bro, can you just keep your hand on your desk? I don't know what you're doing. If Caitlin needs help putting her paper down, we can get her some tape or something, but like, come on. If we try to do radical 40, go ahead and write that down. We can immediately realize it's not perfect because 5 times 5, 25, 6 times 6, 36, 7 times 7, 49. Crap. So this is between radical 36 and radical 49. It's between, what's radical 36? And we're just going to work in positives most normally. Be ready to do those positive or negatives, but we're going to make our life easy and normally just work in positives. Because when it relates to geometry, lengths have to be positive. Is 40 closer to 36 or 49?
36.
36, right? So now this method gets dedicated to Rachel Shaw. So Rachel, if somehow you end up seeing this this YouTube video, yeah, or if you know Rachel Shaw, she's still in high school. What's the gap between 36 and 49? 13, right? That's the distance between them. How much of the gap has 40 already covered? 4, right? Because from 36, it's gone 4.
Oh.
Hold on.
I remember too.
Somebody with a calculator, type in radical 40. Marley, do that. Then George,
Yeah.
do 6, and actually just do 4 divided by 13.
Okay.
So what is the actual radical 40? 6.3245.
Yeah.
It's kind of a fun number. Sorry, I was looking at Marley. Sorry. And then George, what is 4/13?
0.3076.
You will be accurate out to the 10th place at least. Almost, well, a lot of them end up accurate at the hundredths too. If we round this, it's 0.31. If we round this, it's 0.32. This is 100th off. And this is just an approximation. Now, if you want to be accurate, you use your calculator, you type in square root, you get your number. But if you're just trying to approximate where the radicals are going to end up, this is a really good method. What's the gap between the perfects? How much of that gap has been covered? Right, part compared to whole. This is a very good method, at least for the small radicals too. I forget, we experimented with this. I forget if it gets more accurate the higher up you go, or if it gets slightly less accurate. We might have. We might have touched on it in the 7th grade content,
That's what I thought.
but this is where it comes back around.
Yeah,
So, this is really all the base knowledge you need to know about square roots and squaring. I want to get you guys your tests back so you can talk about these real quick. So yeah, we're going to move on and do that. So, if you want, you can go ahead and put your notes away. This is going to take me a minute to pass stuff out. Connor, coming down to you. Dim, sorry. You're the BB. It just messes with me. That both your names are BB. I think we needed to do some more practice. Sorry. Again, I was looking. I hate my brain. Guys, I have a few really weird things about my brain. I could tell you plenty of stories, but like, so last night my buddy had a bunch of money from his school t-shirt sale, and I was helping him double check count it, just so he like made sure he had the exact amount. I put all the bills facing the same direction, all face up. Like, that's one of those things, like, I don't know, my brain just works in a weird way. Even though you can count the money without the, like, without sorting, My brain isn't gonna let me do that.
I have to sort the bills into how much everything
Oh, I
is.
got stuck to it.
Yeah.
Sorry. Your guys, hey, make sure that you only have one test. Your staples like to get stuck together. I don't know why. Well, I do know why because they're staples. So look through your test. Some of you are getting back Chapter 7 revision. Some of you still haven't turned in Chapter 7 again from when we went over it as a class.
No, I didn't.
And some of you are getting homework back or corrections back.
I see what I got wrong. This is 17. Yeah.
And I believe we talked about this before break, but we're going to go ahead and say if you mastered Chapter 8 first time around, you don't have to turn in your practice work. So if you did not master Chapter 8, please turn in your practice work by Monday, so you have the weekend in case you need to go back and do some of those. But if you got a progressing, I'm willing to put money on the fact that you probably didn't do enough practice or care enough about the practice. The answer keys are in Schoology, and again, you are doing practice work for you, not for me. You're doing it for you. I may very well do that with every next chapter we have, where if you master or exemplary the test the first time around, I don't care to see your practice. But that doesn't mean don't do your practice and then hold your breath. You won't master. I guarantee if you don't practice, you won't master. Wow, we had a lot to get back to this.
I don't know how I got that one. I guess it's just my best.
Oh, yeah, I did.
Yeah.
On the big circle, and then the chapter question mark next to it.
Give me just a second. I only have like 5 of these left to give to people.
And then I have my chapter 9 notes, which I have all my blanks on. And then I have my chapter 8 notes.
All right.
I have my chapter 6 notes. Never have my chapter 8 notes.
If I can find a blank copy of your Chapter 8.
Mr. Richardson, it says on the map that chapter 7 is missing.
Still?